Alright, now we're going to get into part 3. This is just a short part. Okay, let's shape or form ceramics. So forming ceramics, it's just a process, just a common word for processing. Okay, we call it forming processes. It's just processing ceramics. So forming processes, they begin with careful preparation of powders, because all products, how the different quality, that you're making different products depends on what's in your powder, and how you mix them. So the transformation into carefully processed powders into desired shape is usually accomplished by one of the following green forming processes. Green ceramics, meaning it's just the products, made with ceramic powders. We call them green products. So here we have different forming processes that we use to shape them. We have casting, extrusion, jittering, die pressing, isostatic pressing, tape casting, and injection molding. So we know this extrusion, injection. Okay, you already have an idea how to do that. So try to remember this traditional little bit of black and white picture, in previous lessons. So here you can see the manually pouring into a mold. Molds usually they have like a different hair, sometimes 4 quarters. I like doing it. Okay, so you're welcome to visit my place in Montana. So I have like about 23 acres up there. I don't have a house. I only have like cabins, 3 of them, and those are what I play. So one student asked me about what do I do for fun. I like to make things and I like to create things. I definitely love to be on the ground doing something than being inside of the house. Yes, I enjoy outdoors. I think, or being outside, especially I like to do things on the ground or trees or outside doing something. So those are what I do over there, like make papers or melt metals or melt. You can buy the block of clays. Okay. I also do construction by myself because I want to build my own place. I don't want to hire anybody and see how much I can do. It's pretty fun for me to do that. I enjoy being alone than going out with so many people. So I don't know why. I'm typically a very shy person, and it's very, I don't know, like you will feel very quiet if you are in a very remote place. Okay, just you and the mountains and the ground, in air and some trees, and you can create things that you cannot be able to do inside of the city. Okay, let's move on. The post-processing of ceramics is both difficult and also expensive. We already knew ceramics are hard, brittle after they are fired. And we always need expensive tooling. And we need time-consuming processes to machine them. So most forming processes, we design it to produce a finished product or one that requires very little post-processing, okay, to avoid this expense and difficulty. So most forming processes, they produce, again, green ceramics. In green ceramics, they have very, very low stiffness. Here it is showing you how you're shaping your ceramics in the mold. And here is you're using automation, okay, to shape the ceramics and form your green ceramics right there. Green is not the color, it's just the immediate products of ceramics after forming. Okay, casting. So in casting, we're going to take a look at slip casting. So most of the ceramic products are formed by this method, casting. And we have two casting. The first one is slip, and the other one is solid. So slip casting, it is used to form hollow shapes such as toilet and sinks. Slip is a low viscosity ceramic slurry. Okay, slurry is nothing but you mix and then form a slurry. And slip is poured into plaster. Okay, we're gonna pour it into plaster. So here you can see your slip right there. And this one is we are making slurry. Okay. And then you're gonna pour it into plaster of Paris mold, which is in the shape of your product. Yeah, it's a very easy process to do. And your product coming out, okay, and that we call it green ceramic or green product or green body. Yeah. So here is a cartoon picture, and you can see right here we're mixing. So that's you're preparing your slip or slurry. And then we're going to put it in the mold. This is your plaster mold. And it's just showing you how the liquid fill inside of that mold. We're going to tighten the bulb so it won't leak out. Give it a time. They're going to form the cast. Then you're going to drain it. In order for you to make the hollow container bottle, so here in this case is a pot, you've got to drain the interior part of it. And in order to pour this liquid and keep that as a liquid, you have to play with the temperature, temperature very, very accurately. Otherwise it's going to be everything is going to be jumbled up right there, and you're going to have a big mass or solid chunk. So going from here to here is a secret of slip casting. We will control the time, the temperature, and then the pressure. Drain it. You will get your drain slip. Now dry it. And then you're going to separate your product out of the mold carefully. The mold got to be perfectly prepared, otherwise it will get stuck right into the product and you're going to have an issue right there. So you will put some chemical that is not going to permanently stick your product material or your slurry to the mold. So these are the secrets of how to. So when you actually do molding by yourself, you're going to bump into so many roadblocks. First you're going to bump into the mold and your product. They stick together and won't come off. Second one, it won't drain. So definitely prepare the slurry in a way that they will come off and they will drain. The interior part will drain. Now here is your finally you dry it in the oven. Or you can bake it outside as well. And this is called your unfinished, where all your green product is going to come out. I think you got the idea. Your toilet, your sinks, many different kinds of bathroom and kitchen stuff made by this way. This is a textbook version or picture. They're pretty simple. You have your plaster mold. You have your slip right here. The slip is poured into the mold. And here water is absorbed by the mold. So this mold is prepared to absorb the water from the slip. And the excess water or excess slip is going to remove by draining it out. And then the finished hollow part, right? It's right there. And then you follow your drying process and then get it out of the mold. Solid casting process is the same as slip casting, but the mold includes a riser column, higher column, okay, to feed the slits, and they use a capillary action. So slip here, you can see, is poured into the mold, and then ceramics, okay, leave it for a time, and it's gonna solidify. And here you're gonna get your finished part, okay. Extrusion, kind of a review from your plastic, but this is a similar looking, okay, extrusion instrument. So ceramics can be extruded using a screw extruder. And don't forget your heat barrel and your hopper. This is where you're gonna add your slip right there, okay? Or I would say just slurry for ceramics. And then you're gonna use your motor. It can also be done manually by using your hand, okay? So it depends on types of motor right here. It's just a mechanical energy that you are supplying to push this screw, okay? And again, you have to heat it. Then you pass your die head right there, your cavity. So we make bricks, pipe, ceramic tubing, and some electrical ceramic components are formed by your extrusion. Jittering, we make dinner plates most of the time by using this method. So don't pay so much attention. We don't have to go into details. So if I give you this diagram, then you should know that's jittering, yeah. But for this class, for this semester, just stick to your questions, assignment questions again. So just read this for your knowledge. So when you want to do a play, okay, if you want to play like me, then you will, you can try jittering. Yeah, outside. We're gonna have a machine shop as well downstairs, but I'm not quite sure that we're gonna get into the industrial material as well. But in the future, we will do this and that, yeah. So students can play with it. The plastic mold is right here, and you're gonna put your clay slug here, and then apply a force to form. Okay, so this is you're doing a forming process by using this type of technique, jittering. So as you can see, jittering involves placing an anchor ceramic body or your clay between the matching halves, right, of the mold. One half of the mold is going to apply pressure, while the other half is going to rotate to produce that finished part. Okay, here's a 2 dimension, so you can't really see it, but jittering means like right there, rotate, yeah, under a force. Die pressing is a little bit different. So this process, it uses steel and carbide dies and water force, hydraulic force. So this force is applied to clay and conform it to the die cavity in a tremendous load. So then the conformed clay is heated. A variety of products including ceramic floor tile, ceramic wall tile, and many electronic components are made with this process. So here die processing of ceramics involves again heat and pressure. Yeah, pressure is very important if you want to shape complex, complex design, because you can't just push it so fast. They're not going to form in the way you want it to go. Yeah, so you will play with heat, and then you're going to play with pressure. Isostatic pressing, more complex ceramic shapes are made. Again, your key point is right here, complex shapes made with isostatic pressing. Careful with your heat and pressure, you know. So this method uses pressure vessels to apply fluid pressure to the outside of the mold. So here you can see the roll bag with a metal cylinder where you put your ceramic powder, and then we're going to use your fluid pressure, and then this is your pressure vessel right there. Okay, it's just pressing. You pressing means like applying a constant force, okay, to shape the product. Tape casting, you need to pull, so therefore we're gonna set it up in this way with some pulleys right there here. So this is a primary process used to form ceramic substrates, and we use this instrument to make integrated electronic circuits. So tape casting involves drawing a powdery, okay, slurry right there. See that line right here, controlled by a gate. So here we're going to put your ceramic slurry, and then you're going to pull that powdery slurry, okay? And here, this is your blade. So enter a blade or a gate right there. Pull it to form a thin layer, okay, on a moving plastic belt. And then here, roll it up, and that's your green product right there. This is just showing you that this slurry is going to load on this film, okay? Because you need a surface to pour the ceramic slurry on it, and then you pull with this motor mechanic force, okay, to that direction down. That's just drying, okay, drying on chamber. But it's more also like the shaping structure, because you gotta go through underneath that surface to, yeah, and go to the other side to be rolled. Injection molding, it's kind of a review from your plastic. It's the same as your injection molding for plastics. So here's your hopper, you know, throw your slurry right in there, or your ceramic powder. You can heat it up, okay? That's your heat barrel right there, and your mechanical forces right there. You're gonna push the screw, right? And then it'll come out from your die head. What are we making with this process? We make, again, complex solid shapes. Post-forming process. We don't want to do post-forming process because it's expensive and difficult, but sometimes you have to do. So post-forming processes, they start with drying process. So the purpose of drying is to remove moisture from the green ceramic body. So when you get your product, you're going to get rid of the moisture first before densification takes place. So densification involves you're going to reduce your void, so that's reducing the porosity, okay, of your ceramic body, and then form a dense part. So densification is achieved by reducing, again, voids or porosity, and we do 3 different techniques. One is sintering, in which we use high pressure and viscous flow. Hot pressing, we use graphite die, pressure and heat. Hot isostatic pressing, HIP, we use high temperature. And gas for complex ceramic bodies. So those are everything that we use in post-forming processes. Okay, that's it for part 3. Again, concentrate on the questions in the assignment, right, out of your textbook. For this major and for this semester, I do encourage you to read. Okay, if you have time, please read the entire handout. If you have money, just get the book, because all textbooks they're very good. Okay, and so if you want to stay in the same major, and you definitely want to make a living out of this, you must have them. Okay, if you don't have money right now, just write down the textbook name and keep it, and when you have money, buy it, because you will need it one day. Okay, I have nothing but textbook, and every time I need something or write something, I have to go back to that. Okay, and it's very, very valuable. All right, that's it for part 3.